Here we can see the critical moment of the innovation in the lithium-ion, or generally battery technology for light electric vehicles. These are 4 bikes from 4 years of the X-energy test, and these 4 bikes are good documentation of what has happened. We can see there are 4 batteries. Actually, here we have also the battery cells for illustration. And first, the Giant L3. It was tested in 1999, and the battery was 10.1 kilogram heavy, and we had a range of 15.9 kilometers with this bike. A year later, the Sachs Elo Touring was tested with not anymore lead acid battery, but this time with a nickel cadmium battery. The battery was roughly half the weight, 5.3 kilograms, and the range dramatically improved with 34.7 kilometers. And in 2001 we had Yamaha Easy Super with a nickel metal hydride battery and with 4.2 kilograms. You can see not a big weight improvement, but the density, like on the left side the Elo Touring pack, still very huge, and the nickel metal hydride battery pack almost the same weight but much more dense. And then the big disruption has happened in 2002. The NEC Torkin battery technology in the Panasonic VV pedelec, first introduced to the market. The battery pack is very lightweight. It's 1.6 kilograms. You know, just 4 years before we had more than 10 kilograms. And the range was still pretty good with 37 kilometers range. So it has had the highest range and the lowest weight. What is going on here is very dense energy. Actually, this was the first time a vehicle in a mass production was running on a lithium-ion battery. The first vehicle running on a lithium-ion battery to transport humans is this one. This is from a university from Switzerland, and they made this record vehicle to cross Australia with a team, and this was Kokam cells from Korea. But this was all kind of lab use, not any kind of production. So this high energy density comes with the risk that this energy want to go wild, so that it catches fire during transport or during use. That's why when you ship it, it must be in specific containers. They can have different, it can be a steel drum, they can be like this, a plastic container, or even a special carton box which is certified. And very precise described packaging materials. Why? Because already cargo airplanes crashed because batteries inside the cargo planes catch fire, pilots died, trucks catch fire. So that's why the United Nations have these transport rules. So the United Nations have a category for this. It's category 9, miscellaneous goods. And that's why also lithium-ion batteries should not be charged at home, in your living room. They should only be charged in a secure place, like where you have protection, like in an oil heating room or in a garage where you usually keep your combustion engine car with gasoline, diesel inside the car. So that's why it's not a toy. You should not charge it in your living room. That's something usually missed by the bicycle dealer to tell you when you buy your electric bicycle or your electric scooter.